Okay, ladies, I wanted to show you an example of a uniqueness proof. And this is starting from section 1.6, but you'll see as we go along in the chapters and in the sections. And actually, I forgot a section, which we're going to come back to, but you'll see as we go further along, there might be proofs that ask you to prove that something is unique. And the structure is sort of similar, just depends on what you're given and what's needed to be proven unique. But I wanted to give you an example. Since I didn't do one in class, I decided to do a video. And this one is pretty straightforward. This would be something inverses, I guess, in pre-calc pre-calc is where you would learn this. So let's look at this proof. Let x belong to the reals and f of x equals x plus 2 over 3. Show that f inverse of x equals 3x minus 2 and that this inverse is unique. So there's a two-parter, and more than likely, unless the first part of the proof is given to you, the uniqueness usually comes prove something first, prove something exists first, and then prove that whatever you just proven is unique. All right, so we first have to prove that f inverse, this right here, is the inverse of that. And I put a little recall in case you forgot what it means or how to algebraically show that a function is an inverse of another function. So in order to do that, you actually have to show that f inverse, you have to do the composition of the two functions, and you can do f inverse of f of x and show that it equals x, and f of f inverse to show that equals x. So once you do that, then you've proven that those two are inverses of each other. Okay, so let's look at this. Okay, so let's start our proof. Well, first, let f of x equal, and if you want, you can say let x belongs to the reals. Since it's given, sometimes, it's okay to put in your proof. I'm not going to mark you off if you put it there, but once it's given at the beginning, like sort of in the beginning before you start a proof, sometimes you don't need to put it, but it's better safe than sorry, so we'll put it in. Let f of x equal x plus 2 over 3. Okay, and we have to show that the inverse of f is this function f inverse 3x minus 2, okay? Well, we're going to say this. Because we don't want to call it f inverse yet, because we have to show that, let that equal g of x. So let g of x equal 3x plus 2. Minus 2, I'm sorry. 3x minus 2, okay? So, and let's just compose the two. So f of g of x equals f, and remember, start with the inside function, so that would be 3x minus 2, and that would equal, wherever we see an x in this function here, we're plugging 3x minus 2, so 3x minus 2 plus 2 all over 3, and that equals, the 2's will cancel, 3x over 3, the 3's will factor off or become a 1, and we're left with x, okay? Also, g of f of x, so you have to prove it both ways. And so that's g of x plus 2 over 3. And so now this is 3 times x plus 2 over 3 minus 2. And that equals, the 3's become a 1, and that's x plus 2 minus 2. And so that equals x. Okay. And so from there we can say, thus, g is the inverse of f, and hence f inverse of x equals 3x minus 2. Okay, so that's sort of the first part of this proof, is to show that function is an inverse, and we just showed that by taking the composition both ways and showing that it equals x, because as you may remember with compositional functions, they're not necessarily commutative. Okay. And so we just showed that we'll get x if we do it both ways. Okay. Now let's show, so part 2 is to show, we got to show uniqueness. And the general structure, so to show something, that spells uniqueness, it looks kind of funny. But to show something's unique, you assume that two exists of whatever that something is, and show that those two must be equal. Okay. So in other words, in this case, we have to say if f inverse of x equals f inverse of y, then x equals y. Okay, and again, depending on in different contexts, this will be the setup. We're going to assume that two things exist and show that those two things are the same. So basically, we're assuming that these are two different things. That's why we're using two different variables, but in fact, we're going to show that they equal each other. Okay, so we know how to do an if-then proof. Suppose f inverse of x equals f inverse of y. Okay, and we have to show x equals y. Okay, so, or if we're supposing f inverse of x equals f inverse of y, and we already know again f inverse of x we stated was 3x minus 2, then we can say 3x minus 2 equals 3y minus 2. Thus, 3x equals 3y. Therefore, x equals y. And so we can do a final, therefore, putting everything together, f inverse of x is 3x plus 2. Wait, is it 3x plus 2 or minus? It's minus 2. Minus 2. And this inverse is unique. Okay. So again, we'll see more proofs involving uniqueness. I just wanted you to have this one. So make sure you write this in your notes.